Hello, is everyone there? Shall we start? Shall we start? Everyone there?
Yes, sir.
All right. We'll wait for one more minute. I think everyone has come. All right. Hello, can you guys see the screen?
Yes, sir.
All right, all right. Good evening, everyone. Today we have to do some revision and some numericals related to Newton's laws of motion, right? Same thing?
Yes, sir.
Okay. You must have understood. So we'll be starting basically that Newton had three basic formulas, basic relations. Okay. That is called Newton's laws of motion. The first law was related with the inertia, right? Okay. First law was related with inertia, NLM. Second law defines the force as the rate of change of momentum. And the third law is action reaction forces. Right? So we'll be having some questions related to the same thing. And that's how we'll be completing this chapter. Right? Okay. So let us start with the first question. I'll be just giving you questions from each and every topic so that you understand. And even I would understand that you have understood the topic and the subject too. Right. So let us start with the questions from inertia. But I think inertia would be having no questions at all. Right. Let us start from the second law. That is the rate of change of momentum. So for has got its two aspects. One, if mass is constant. If mass is constant, so it will be m dv by dt. If mass is constant, it will be m dv by dt. Otherwise, if mass is not constant, velocity is constant. Mass is not constant. So it will be v dm by dt. Have you seen this case, the second one? Have you seen the second case? Amrisha, Arvind, Kavya? No, you must have seen that. Vandana, Shweta, Ritika. Why not answering? Shweta, are you there? Manna?
Yes, sir.
All right. So this case you must have seen in case of rockets,
Yes, sir.
where the fuel starts burning. And if the fuel starts burning, the mass starts depleting, right?
Yes, sir. Yes, sir.
Yeah, you must have solved that question also. It's going up like that. So as the fuel starts burning, the rocket mass starts depleting. So there is a rate of change in the mass with respect to time. And since the rocket has overcome the gravity, so it will try to maintain its velocity constant. It just need to overcome the gravity. All right. Okay. I'll be giving you the basic question. First question says that. First question says that a force of 72 dyne, force of 72 dyne is inclined to horizontal, is inclined to horizontal, is inclined to horizontal at an angle of 60 degree, at an angle of 60 degrees. Okay. Find the acceleration in a mass of, find acceleration, acceleration in a mass of 9g, 9 grams, which moves in horizontal direction, moving in horizontal direction. Try to solve this. Try to solve this.
Over centimeter per second.
How much?
4 centimeter.
4 what?
Centimeter per second square.
4 centimeter per second square. That's correct. Arvind said the answer. Anybody else?
So what is the theta value?
Theta 60 degrees. 660.
Okay.
So this becomes mass acceleration. So it's left.
Yes, sir.
Got it, everyone?
Yes, sir.
I'll still solve for those who could not solve it. So thing is that we have a mass. So force of 72 Newton is being applied uh, to it. So let us say that it is in this direction. 70, 1 minute. We have mass here and 72 Newton is being applied on it like this. 72 dyne, sorry, not Newton, dyne. Dyne is the CGS unit of force. What is the numerical value if you want to convert dyne into newtons?
10 per 5.
10 to the power 5. Good. So this angle is 60 degrees. And this is moving in horizontal direction. So horizontal force will be responsible for horizontal acceleration. A. So what is horizontal force? So this 72 into cos of 60 degrees. So this is the force. Will be mass times acceleration. Mass is 9 grams. So just have to equate this 72 cos of 60 degrees is equals to 9 into A. From there we'll get A in centimeter per second square. Good. Okay, let's move on to the next question. Next question. Hello. Actually, the net went off 1 minute. Actually, the net went off suddenly 1 minute. Can you see the whiteboard here? Can you see the whiteboard here, everyone?
Yes, sir.
Okay, just for 1 minute, because I lost my host position, so I cannot share it. They'll be providing it me within 2 minutes. So question says that till then, position coordinate of a body moving is given as a t to the power 4 minus b t to the power 3 plus ct. Okay, so this is the position coordinate. You have to find if the mass of the body is m. The mass of the body is m. So you have to find the force at any t time. What will be the force acting on that particular body at any time t? That is all this. Force acting on the body at any time t. Tell me the answer. Everyone. Arvind, are you solving?
Yes, sir.
Or shall I tell the answer? Or you,
Sir,
or you
one
want to
minute,
wait for
one minute, sir.
Okay. Vandana,
Yes, sir.
Sir,
solving or not?
1280 square minus
Go on, go on.
1280 square minus 6bt plus c. Oh no, no c. 1280
The
square
answer says
minus 1280 square minus
hmm,
6bt into mass.
to be multiplied with m, that will be the force. So what you just have to do, that's correct. What you just have to do, if x is equals to at to the power 4 minus bt cube plus ct, if you differentiate it once, you get velocity, right? So it will be 4at cube minus 3bt square plus c. If you differentiate it again, you get the acceleration. So it is 12at square minus 6bt. C becomes 0. So this is your acceleration. Acceleration multiplied by mass gives you force, right? Okay. Next question. Next question says that a balloon has a mass of 5 grams in air. 5 grams in air. The air escapes from the balloon at a rate of at a rate of 5 centimeter per second. So if the balloon completely shrinks in 2.5 seconds, find the average force on the balloon. Find the average force on the balloon. Okay, so you have to find the average force on the balloon. What is happening here? There was a balloon. Okay, it was blown up, air filled in it. So after 2.5 seconds, this completely slashed. Okay, let me draw it better. So balloon is fully blown. Okay, it was the, let us say that there was a pinhole and the air inside it was constantly coming out of it. Okay, at a constant rate. That rate has been given. Okay, that was the decrement of the rate. That was the constant rate with which the balloon's air inside it was coming out of it. So after 2.5 seconds, this was the total air inside the balloon was out of it. That is the unblown. So you have to find the average force on the balloon which was acted during the uh, exclusion of the mass or of the air that was present inside of it. So here, basically, you have to you have to make a concern of what is decreasing, because force was what? Force was the change in momentum, dp by dt. Force was the change in momentum, okay, and momentum is m into v. So now you have to see that which part of this is changing with respect to time.
Sir,
Yeah,
is it 10 dyne?
yeah, 10 is correct. How did you solve it? Can you explain it?
Sir, force is equal to change in momentum by time.
Okay, and how momentum was changing?
Sir, 5 into 5, which is mass into 5 meter per velocity.
Mass into velocity.
So
Yeah,
dm by
that was
dt
the
will be
initial
0.
momentum. Okay. Then
Divided by time, sir.
see, you have partially understood the question, I guess.
The
Basically,
change
you are
in
correct.
mass, rate of change of mass into
Yeah,
velocity.
exactly. Vandana, you are correct. But the thing is that you need to understand one thing here, that here mass was changing. Earlier it was 5 grams of mass. Okay. And let us assume that the total mass was due to this air inside it. Now the mass is 0. If we assume that the total mass of the balloon was due to the air, I'm underlining this word, this sentence. Okay. Now let us say that mass is 0. Okay. Excluding the mass of that outer covering of the balloon. Okay. So change in mass was there. Change in mass was there from 5 grams to 0. Was there a change in velocity during this process? So velocity was constant, 5 meter per second. Sorry, 5 centimeter, na? 5 centimeter per second. The velocity was constant throughout the process. Got it?
Yes, sir.
So basically, in this process, dmv by dt, our mass change and velocity was constant. So velocity will be out of differentiation. Now dm by dt, rate of change of mass with respect to time. So velocity was constant, 5. What is the rate of change of mass? It is 5 minus 0. And what is the time interval? That is 2.5 seconds. So you have done the same thing. But this is what you need to understand.
Okay.
Now you'll get the answer 10 times. Understood?
Yes, sir.
Everyone, did you understand or not?
Yes, sir.
Chitesh, Kavya, Meghna, Nivedita. At least tell me yes,
Yes,
so that
sir.
I can move forward. All right, good. Okay. So this was 2-3 questions from the rate of change of momentum part. Let us solve some questions related to impulse. Prior to that, I need to discuss something. You know what is impulse?
Change in momentum.
Impulse, pardon?
Force
The,
and
the change in momentum, force in time.
Yeah, force into time. Or we can say that just change in momentum, not rate of change. Rate means with respect to time. So we can say just change in momentum. We know now that force is equals to change in momentum per unit time. So if you take time the other side, it will be this, the same thing. Okay. So either we can say that force into time is impulse, or we can say that rate, just change in momentum. Okay. One more thing. Force can also be calculated by calculating the area under force time graph. If you'll calculate this area, you'll get the impulse. All right. Another way, impulse is related. Impulse is shown with this letter J. So it is integral of f dot dt. If force is given in some time relation, okay, some relation will be given to you in terms of force. For example, force is directly related to time as at to whatever function it may be. So you can integrate it to get the impulse with respect to time. All right. So these are few methods through which you can calculate the impulse. Let us solve some questions related to it. Okay. Question says that a machine gun fires n bullets per second. A machine gun fires n bullets per second. Uh, mass of bullet is 40 grams. I'm just writing the question crisp, okay, not the whole sentence. Speed of bullet is 1200 meter per second. Okay. The person holding a gun can exert a maximum force of 144 Newton on it. Person holding the gun can exert maximum of 144 Newton on it. So what you need to do, you need to calculate n. calculate n. Now see here, what this question is asking. Have you ever tried to fire a bullet from a gun? Anybody has a gun? I don't think so. All right. See here. If we fire a gun, the gun has something called recoil. You know this,
Yes, sir.
right? So recoil is based on what principle? Can anybody tell me? Recoil works on what principle? Anyone? Wild guesses?
Newton's third law of motion.
Action reaction. Can be said like that, but the thing is that basically they work on conservation of linear momentum, principle of conservation of linear momentum. Okay, so whatever momentum was there initially, it has to balance the same momentum. So you see here, if we fire a bullet, how much momentum it generates? So mass is 40 by 1000 into 1200, this much momentum. So this is around 48 kg meter per second. So same momentum it has to generate. Now see here, if we make the this momentum has to be generated in the this momentum was generated in the forward direction, and same momentum has to be generated in the backward direction in order to balance the momentum. Why? Because initially all were at rest and momentum was 0. So 48 kg meter per second should also be there back side. Now see there, if we have the mass of gun, let us say 5 kgs. So 5 kg into velocity is 48. So velocity will be 48 by 5, that is 9 meter per second. 9 meter per second. Okay, that should be the velocity of the gun at the backside. So you have to balance this out. Whenever you try to, I've just taken an example where weight of the gun is 5 kgs. Okay, generally it is more than that. So it generates. Now see here, if if the change in momentum was there, because gun was initially at rest and finally you gave him a momentum of 48, so change in momentum was there, some time period was also there. Okay, let us say that it generated this in 1 second. So 48 by 1 will be your force, 48 newtons. Are you getting my point? So let us say that in 1 second it fires one bullet. In 1 second the gun fires one bullet. So in 1 second only this momentum got generated from 0 to 48. The gun generated this much momentum in 1 second. Agree or not?
Yes, sir.
Right? If the gun fires one bullet in 1 second, so the gun also acquired a momentum of 48 from 0 in 1 second. So this will be the force, 48 Newton. Underline, if gun is firing one bullet per second. So this force you have to balance. You have to provide to the gun, otherwise you will break your shoulder. Are you getting my point? Everyone? Everyone, is there any doubt?
No doubt, sir.
What
Alright.
is that 5 into what is that 5 here?
This 5. So I was just this working is not related with the question. I just tried to explain you the question. I assumed what happened here, that according to this question, the mass of bullet was 40 grams and the velocity of bullet was 1200 meters per second. So if you multiply that, we get a momentum of 48 newtons. Earlier both were at rest, so initial momentum was 0. Now the bullet gained a momentum of 48 kg meter per second. Okay, sorry, 40 grams it was now. 40 grams meter per second. Okay, 40 grams meter per second. Oh, no, it is kg because we converted it to 40 by 1000 I did. All right. So 48 kg meter per second was the momentum attained by the bullet. So same momentum should be there in the backward side so that they both gets cancelled and they should become as the initial one. Initially, the momentum was 0. So let us assume that the mass of the gun was 5 kg. So 5 into V is 48. So that means velocity acquired by the gun will be 9 meter per second. With that, the gun will acquire a 48 kg meter per second momentum because initially it was 0. And if we are assuming that the gun fires one bullet per second, so it will be from 0 to 48 kg meter per second momentum, change in momentum per second. That will be the force. So if I'm underlining the word if, the gun is firing one bullet per second, so this will be the force that will be transferred to your shoulder. And the question says that the maximum force that the shoulder can have is 144 Newton. So you have to check that this machine gun can fire how many bullets per second. Okay, that n you have to calculate. Now you solve it. Did you understand this procedure?
Yes, sir.
Now you try to solve this question. Calculate the value of n that can be fired from the machine gun so that it can balance the force. The shoulder of that person can provide only 144 Newton.
So I found the time value.
Time value means?
Like I got the time now. I did F is equal to mv by t,
Hmm.
and I got the time value as 1 by 3 second. So should I multiply n with it, and is it 3 bullets then?
See, you got that in every 1 by 3 seconds, you can fire one bullet, right?
Yes, sir.
Huh? So in
Yes,
1 second, because we have been asked about per second, n bullets per second. So in 1 second, how many bullet can you fire? 3?
3.
That is the correct answer.
Very good, I got 3.
That's good. See what we have to do. So force is nothing but mv by t, momentum by time, and this is by one bullet. So we'll be multiplying it with n number of bullets per second. So per second means what? Our time period is 1. So force is maximum 144, and we don't know. Mass is 40 by 1000. Velocity is 1200, and time we need per second. So put it 1 itself. From there you'll get n is equals to 3. Otherwise you'll get t is equals to 1 by 3. So what you did, Kavya, you put n is equals to 1. You found that in what time interval I can fire one bullet. So you got that in every 1 by 3 second I can fire one bullet. That's what you got. Understood?
Yes, sir.
So ultimately you can get it like that. But this is the correct way. Everyone understood? Yes or no?
Yes, sir.
Ananya, Chitesh, Kavya, Meghna, everyone.
Yes, sir.
All right. Let us move on. Next question. Okay. Next question says that we have a ball. This is the wall. We have a ball moving this way, strikes the wall, and it gets reflected back. Angle of incidence and reflection is same, 45 degrees and 45 degrees. This is coming this way. Okay. Initially, the momentum carried by the ball is 5 kg meter per second. You have to calculate the change in momentum. Calculate the change in momentum. Solved? Any answers? It should not take this much time. Shall I do it?
So,
Yeah.
I found the final momentum minus initial momentum.
Okay. Yeah, that's what you have to do. What answer did you get?
But I'm not sure if the answer is right because I'm confused at this point.
No problem. Give me the answer.
I got minus 2p cos theta. Should I continue this thing?
Exactly. That's correct. Minus 2p cos theta. But you
Oh,
need to solve it.
yes,
It
one.
is minus 2 into p is 5 into cos of 45 degree. So you'll get as minus 7.07 kg meter per second. Now I'll tell you how to do this.
I got minus 5 root 2.
5 root 2, if you solve, you'll get this
Okay.
kg meter per second. See, basically, let us consider this to be in a coordinate system. Okay, this is coming this way, this is going this way. All right. So this is y-axis, this is x-axis, this is minus x, this is minus y. Let us say that this is p and this is theta. So this coming ray can be written as, can I say that this is this way and this way? So it is either, it is, I think it can be written as minus p sine theta j cap and then plus p cos theta I cap. Do you agree with me? P initial. Do you agree with me? Yes or no?
Yes, sir.
All right. So P final. P final. Will tell me what will be P final then? Arvind? Tell me P final. Amrisha, you can go on. Anybody can go on. It's easy. If this has this arrow, so it will be this side and downward side. So I think it will be minus P. Again, this is theta. Minus P cos theta I cap and minus P sine theta j cap. Do you find it correct? Do you find it correct? At least say yes or no. You have that option, no. I'll explain it again.
Yes, sir.
All right, all right. So what is change in momentum? P final minus P initial. What you remain with is minus P sine theta j cap. And then again, minus, no, sorry. You remain with cos theta, na? Minus P cos theta j I cap minus of plus P cos theta I cap. So it will be minus 2P cos theta I cap. So you just put the values, minus 2 into P is already given 5 and cos of 45 degrees. So you'll get minus 7.07 kg meter per second. Everybody understood? Yes or no?
Yes, sir.
All right. Have you written this? Shall we move on?
Yes, sir.
Okay, 1 minute. Next question. Next question. Question says that a 30 kg shell, is flying at 48 meter per second. 48 meter per second. When it explodes. When it explodes. Okay. So it explodes at the top. So it's one part. It's one part. It's a one part of 18 kgs. Of 18 kgs. Stop. One part of 18 kg stops. While the remaining part flies on. So one part stops and the remaining part flies on. So you have to find the velocity of the later. Find the velocity of the later. Let us solve this. This is easy. Let us solve this.
120 meters per second.
Do it as fast as you can.
120 meters per second.
Pardon?
120 meters per second.
120 meter per second. That's correct. Good. Everybody try to solve this. Okay, I'll give you the hint now. It is based on principle of conservation of momentum only. Initial momentum is equals to the final momentum. So what was happening? A ball was flying initially 30 kg in mass and it was flying with 48 meter per second. It must be having some initial momentum, let us say pi, and then it blasted off. So one part finally stopped, it must have fell down, and the other part flew on. So these both should carry the initial momentum. Okay. The initial momentum and the final momentum here, considering both the masses, this is 18 kgs and 0 velocity. And this is the remaining, that is 12 kgs it would be, and some velocity that we don't know. So momentum of this plus momentum of this should be momentum of this. Now calculate the velocity. So it should be 30 into 48 is equals to 18 into 0 plus 12 into v. So v will be what? 30 into 48 by 12. That will be 120 meter per second. Understood, everyone?
Yes, sir.
Good. Let us move on to the next question. Okay, the rocket one. Fuel is consumed. Fuel is consumed at a rate of 100 kg per second in a rocket. Okay. The exhaust gases are ejected at a speed of 4.5 to 10 raised to the power 4 meter per second. What is the thrust? What is the thrust experienced by the rocket? What is the thrust experienced by the rocket? Again, the same thing, same concept, that here the mass is changing with respect to time. It is the mass that is changing with respect to time.
So 4.5 into 10 power 6 Newton.
That's good. That's good. Very good. Everybody got the answer? Please, everyone respond. This is for everyone.
Yes,
If you're
sir.
responding, that I'll know that you are solving it. And if you're solving it, it will be definitely benefiting you. So here mass is changing, velocity is constant, velocity is how much? 4.5 into 10 raised to the power 4 meter per second. And the rate of change of mass is given, that is 100 kg per second. So that will be 4.5 into 10 raised to the power 6 kg meter per second. This was the easiest question of this kind. Okay. Now a good one. A good one. Question says that a balloon with mass m, with mass capital M, is descending down with an acceleration a, right, where a is less than g. What mass m of its contents must be removed so that it starts moving up with acceleration a. So the thing is that earlier what was happening, there was a balloon. Okay, it was descending down. The mass was m. It was descending down with an acceleration a. Okay, that means what? The force of buoyancy that has been acted on it, let us say that FB acted on it, was less than the force of gravity. Force of gravity was greater than force of buoyancy. Okay. In next case, what you have to do, you have to take out some mass from it. Let us say that I took out small m from it. Now the force of buoyancy is same in both the cases, but the weight has been decreased. So weight is what? F of gravity. Earlier it was mg. Now it is m minus mg. So slightly lesser than the earlier previous case. So now FB is greater than FG. And it is going up with an acceleration. You have to find what mass is to be removed so that it goes up with the acceleration.
So,
Yeah.
we should find the mass only, right?
Mass that has been removed there.
It's 2 ma by a plus g.
Mass is
2 ma
capital M A by A plus G. That's correct. So if you'll add these two, you'll take the mass on one side so that you can get it as the variable, and rest all the constants on the other side. You can get the mass as 2 ma by A plus G. If you add these two, I'll do it. It will be mg minus mg plus mg is equals to m plus, sorry, 2m and then minus m, 2ma and minus ma, if you'll add these two. So if you take m on the say one side and you take everything on the other side, you'll get this. Understood, everyone? Everyone, Arvind, Ananya, Vandana,
Yes, sir.
Chitesh.
Yes, sir.
All right. Okay, then that's all for today. Solve more questions. This is not enough. Okay. And I think we have class after half an hour for maths also, right? Be there at 6:15. I'll be there. Hope you don't have any doubt. Shall we end it?
Yes, sir.
Okay then.